Отлично, все.
It looks like it works.
Да, начинаем тогда. Так, окей, поехали. Это Postgres Live, я Николай Самохвалов, и со мной онлайн также Илья Космодемьянский. Привет, Илья.
Привет, Коля. Привет всем.
У нас сегодня необычный ивент, мы продолжаем тестировать разные форматы. Впервые у нас не русскоговорящий гость. Этот гость, он очень заметная фигура. Никто другой, наверное, заменен на, так сказать, Postgres-арене. И очень активный человек. Делает, наверное, думаю, несколько конференций каждый месяц в разных странах, разных континентах, другие события, вебинары, митапы. А что более, наверное, даже важно, этот человек играет ключевую роль в связи между разными частями распределенного сообщества разработчиков Postgres, между разными командами, разными людьми, то, что называется словом координация разработки. В общем, вы, наверное, и так знаете этого человека хорошо, если вы не только что присоединились к Postgres проекту. Это человек Брюс Момджан. Брюс, welcome and thank you for joining us today.
Hello.
I have a huge list of questions. And first of all, I've heard that next month you have big plans for visiting Russia, right?
Yes, I do. And I absolutely wanted to start with that. So thank you. I will be visiting the Postgres conference at Moscow State University in, I think it's February 5 to 7. And then I'm going to be speaking in Rostov-on-Don on the 8th.
Cool.
And then I'm in Yekaterinburg on February 10th on Saturday. So my website has a list of the locations. I don't think we have a location for Yekaterinburg yet. We're not sure what venue we're going to use, but it'll be updated. And I assume you'll probably announce to the group because it's I'm excited. I've never been to either of those two cities, so two more new cities for me.
These cities are very different. It's south of Russia and
in the Urals. So it should be very interesting. I think Ivan's coming with me, and I know I'll be talking about Postgres 10. I'm sorry.
Ivan Panchenko, you mean? Right?
I'm sorry, Ivan. Yeah. And I know I'll be talking about Postgres 10. And also some of the information about what we finished for Postgres 11. So it's kind of February. It's kind of in the middle of what we're doing for Postgres 11, but we'll talk about that as well.
By the way, how you consider Postgres 10 release? How successful it is?
It's funny. Having done this for so many years. What we're really in the stage of is a point where a lot of our very big features are taking several years to finish. So, for example, logic replication, which happened in Postgres 10, had been pretty much worked on for the past 3 years. And if we look at parallel query, that's probably in the middle of a 4-year span. I think partitioning. The partitioning syntax and then the performance features we're going to work on for there is also in a multi-year span. So when I look at Postgres 10, I feel like it's like I'm in the middle of a river. I'm halfway, to the other side, but I have a lot more to go. But I'm happy because a lot of these parallel query and partitioning syntax and logical replication are things we know we've needed for a long time. And a lot of companies or a lot of groups get sort of stuck on these really big ones. And I think we're still learning how to effectively handle some of these multi-year projects. And I think if I look back to 9.5 or 9.4, there's a sense that we were kind of struggling to figure out how to get some of these really big projects done. And I think we now kind of solved that. And I'm very happy with the feature set. The feature set is very strong. But at the same time, there's a lot of follow-up work coming in Postgres 11 and 12, really building on that to enable new workloads. And I think that's one of the more exciting parts about that release.
here I must to ask a question about auto failover. When Postgres will have it like embedded to the core?
Right. So we've struggled with that for a long time. Basically, the community, I don't know how to put this, but the community is really good at doing the database, right? That seems to be what most of our people are excited to be working on. And obviously we're very good at technologically building database software. The problem is we're not very good with tooling. So for example, GUI tooling around Postgres, we're not really good at. Replication tooling we're okay with, but I still think we struggle there. Monitoring, I think I think we struggle with. And I think the kind of integration that's necessary to do auto failover requires really integration of Postgres with the network stack and virtual IPs and some type of watchdog timer and that kind of thing. And we've just never really gotten a sense that Postgres wants to go out into those, what we consider to be edge user interface kind of things. There's not a design goal for that. Obviously, it's not the companies that drive this, because we've had this problem for the 21 years that I've been involved. So I can't blame EDB or Second Quadrant or Crunchy or any of these other companies, or somehow preventing us from developing these what I call edge services. And it's always been something that we felt was best done outside the data. Connection pooling is another classic one, which always seems to be not outside the database. And I even have a blog entry suggesting that we should have some simplistic connection pooling inside the database. And we may eventually improve Postgres so there's some very simplistic failover. In fact, in Postgres 10, we have a libpq capability that allows you to do sort of a poor man's failover at the connection end. So libpq, you can specify multiple hosts, and it'll go to each one, kind of in round robin. As one doesn't work, it'll go to the next one. But we've always kind of deferred to outside projects. pgpool being an example of something that does a huge amount of stuff outside of Postgres. I think the real downside is that people coming from proprietary databases are used to an entire solution. They're basically expecting the database vendor to be providing every solution under the sun, whether it's Golden Gate or it's the Enterprise Manager, Oracle Enterprise Manager, or the failover part, or clustering or whatever. And they're assuming that the vendor who made the database is going to provide all of that integrated in one package. And the community just never been structured that way. And it's a criticism. It's a valid criticism, because you have multiple ways of doing replication, you have multiple ways of doing failover, you have multiple ways of doing monitoring, and somebody coming to Postgres new is thinking, gee, this is a chaos, right? Like, how do I know which failover to use and so forth? But the problem we've seen with the proprietary databases is that a lot of these edge solutions, whether it's monitoring or failover or some of the fancier replication cases or pooling, often require a lot of customization. And if you start to bring that capability, whether it's connection pooling or failover or monitoring, into the database too much, your database starts to look like a database plus A and plus B plus C. And the problem there is that you're starting to get too much, the database product itself starts to become too complicated. So I know it's really confusing to new people when we come in and we say, here's Postgres. Oh, well, I want to do failover. Okay, you got to go over here. Okay, I got to do monitoring. Oh, you got to go over there, right? And I got to do you know, performance analysis, or I want multi-master. Oh, you got to go over the other places, and it's frustrating. It's frustrating, but I guess I don't see that changing because we're so consumed by the database itself, and there are a number of very capable third-party tools. I didn't even talk about backup management, but if, for example, PG Backrest is a good example of an external tool that is really not tied to the database at all. You can use that. You can use something. You can use Barman. You can use a whole bunch of other ones. You can use Enterprise DB's tool, whatever. But they're all really capable, and they kind of have their own development cycle. They have their own feature sets and so forth, and they are successful. It's just taking a while, I think, for these sort of failover tools to kind of get up to the same grade as some of our backup tooling and other stuff. But it's a different ecosystem, and I don't know if that's going to change.
Actually, Bruce, may I ask you about these ecosystem things, because you touched them talking about the autofailover things. Take a look. We have several things in Postgres which now are in the core. Like previously, there was no replication in core. Previously, there was no infrastructure for any sort of backup, and so on. What's the difference, actually? Why those features finally got to the core? How this procedure works inside the Postgres community? Who decides? And what's the difference between features? Why one feature finally got into the core and another one not?
Right, that's a great philosophical question. I have thought about it. So we tend to bring things into the core if there's probably one agreed on approach of how to do something. So, for example, for replication, you know, we had a whole bunch of what we call logical replication tools out there. We had Sloaney, we had Picardo, and they existed for a long time. There's actually a bunch of them I can't even remember anymore that just went away.
Sloaney was probably pre-logical replication, before logical replication.
Right. So pathological replication, exactly. So the logical replication, like if there's pretty much one way of achieving something, then it's very likely it's going to come into core. So, for example, binary replication, it was very clear that was a lot different in terms of how much it was going to need to be configured, how much setup it was going to need, and so forth, versus what you do typically for Sloaney, which, you know, obviously it has a whole plethora of things you got to do to keep it going. So just imagine taking the complexity of Sloaney and bringing it into the database server. I mean, that would be a very scary idea, right? For a number of reasons, but I don't want to beat on them. But the point is that when you have a problem domain that has a whole bunch of different possible ways of going at it and a whole bunch of possible things that you might want to configure, you're gonna tend to not bring that in, because if you bring it into the database, you're giving people one way of doing it. And if you give people one way of doing it, then all of a sudden they're going to want another way of doing it, another way of doing it. And then all of a sudden your database becomes a replication manager, not a database anymore. So when we saw physical replication, it was clear that had to be done in core because it was so tied to the storage format and the way that every object had to have a recovery thing and so forth. And when we ended up doing logical replication, and I'm sure you've seen from how you set it up, and I know my slides actually have an example. It's actually very clean. Like, okay, you make a publisher and you subscribe to it, right? And you do it per table, and there's almost like one way you'd want to do it. But for example, in backup management of backup tools, or failover, or even multi-master, which requires conflict resolution, it's not really clear how that's going to get into core, because by its own nature, multi-master has to have some kind of conflict resolution set up in it. And then how is that going to work? Same thing with sharding. I mean, we've had external sharding for a long time. I think that the barrier of what you need to get sharding into Postgres now has become so much lowered now, because you have foreign data wrappers, you have partition syntax, you have parallelism, you have all the things that are kind of coming together to allow us to do sharding in a simplistic, this is probably the only way you're going to want to do it solution, that we can bring that into core. But if you look for PGXC and XL and all the other sharding solutions like Citus that are out there, up until a couple of years ago, there was a whole bunch of ways you could do sharding. And because there was a whole bunch of possible ways you could do it, it was hard for the community to say, this is the one we're going to enshrine in the Postgres executable and have minimal configuration, and this is the way everyone's probably going to want to do it. So I think the more varied the solution is in the problem domains, I think the harder it is to bring it into core. And I think when one technology like binary replication in some sense logical replication gets to the point where there really is just kind of one agreed on way that we kind of know is going to be the best, and configuration is going to be minimal, that's when you're probably going to want to bring it in. I mean, logical replication is a great example because, as I said at the beginning, took a couple of years to bring it in. One of the reasons it took a couple of years to bring it in is because we needed an API that was super straightforward and simple for people. And because of the way it had been developed as an extension, it didn't have a clean API. And we were only willing to bring something in a clean API. So if we go to the actual question at hand, when would we actually integrate auto failover? Again, we've already integrated auto failure to some extent in Postgres 10 by allowing clients to specify multiple hosts. If the first host doesn't answer, it goes to the second one. I'd love to see auto failover. I'd love to see all these things in Postgres core. But the problem is, if there's not a agreed on way of doing it, and the configuration file for this new feature would be on par in size to the Postgres conf file, then you're like, all right, maybe this may be where we don't want to go. Maybe we want an external project working on this, where you download it only if you need it. You configure it in a separate environment. You work on it kind of individually, and it has its own release cycle. It has its own bug fixes. So, and it can continue to evolve. And if it gets to the point where this is absolutely what we want, which is what happened with logical replication that Second Quadrant had been working on for so many years. When it gets to that point, all of a sudden it's like, okay, we're now going to bring it in and make it, make it part of core. And I think sharding is kind of going in that same direction, where we're kind of taking pieces and we're developing what we think is going to be probably the default solution. And there's going to be other external tools out there still to do sharding probably once we're done. But again, it's going to give us a framework of having, shards, of having transaction manager, global transaction manager, a global snapshot manager, and kind of have that whole partition syntax structure around it and optimization and so forth. It's going to allow Postgres to go to a new, but again, you can't, if we had taken Postgres XC 10 years ago and just brought it into Postgres as is, we would be in a very bad position right now. And I think that's historically how we're analyzing what comes in and what doesn't.
Cool. Let's talk clouds. I think it's related to some extent. If we consider, we all know that Amazon, AWS, Google Cloud, and Azure all support Postgres, and it was
right.
Good news 1 year ago or so when two other big cloud players joined this party. And in case of it's very known, right? And it's like I mean to be better to I have a question from our audience actually. And it's in English, so I can just read it. Postgres and containers orchestration. Any plans to bring some level of support integration with recent technologies like Kubernetes? So the question is, there are things that have which are very popular on the market, and their API is well developed. So why not to bring some features to support them and to be more compatible and so on, right? To the core, actually, to ship them these features, right?
Yeah, I think we have a mixed bag there. If we look at how Postgres is integrated with the cloud, both virtual machines and containers, I think that's a huge success for us. It's a huge success for a couple reasons. First, obviously, the licensing model and the reputation of Postgres allows these cloud providers, whether it's Amazon or Google or Microsoft, right, to deploy enterprise-capable cloud solutions very quickly and very cleanly, and to basically rely on the reputation of Postgres to be high quality and enterprise ready. And that's a win for everybody. And Postgres has gotten a great amount of PR from that. And the cloud providers are trying to work with us to figure out how we can improve user experience and so forth. So I think that's all really, really positive. And one of the reasons it's been so clean and so smooth up until now is because the philosophy of Postgres has always been to rely on the operating system and the tooling in the operating system as much as possible. And frankly, I think we've gotten criticism for that over the years. So, we've just had a whole discussion over why don't we bring things into Postgres, right? And effectively, one of the reasons we've been so successful at being cloud deployed is because we have not brought a lot of things into Postgres, right? So because we don't have special raw devices, we don't have our own sort of job manager and a whole bunch of things that usually get stuck onto a database that make it very hard to operate in a cloud. So I'm thinking special kernel calls, special operating system instructions, hardware, special hardware needs, and sort of going around and doing all sorts of crazy stuff. We don't do that. We're very vanilla kind of database in terms of what we expect from the operating system. So to counter what we talked about before in terms of getting things into Postgres, we actually have a case where we have not brought things into Postgres, and that's actually been a win, because when you deploy Postgres in the cloud, it effectively has no idea it's running on a container. It has no idea it's running in a VM. It's just making kernel calls and it's waiting for something to come back, and we're good, right? So when the original virtual memory cloud things kind of came in, we sort of looked at it and we said, okay, what do we need to do? And we're like, well, really nothing, at least in terms of what we need to change, right? We didn't seem like we needed to change a whole lot. A similar story when SSDs came along, the only thing we had to change was to allow random page cost per table space. Like that was our SSD solution, right? And the reason we didn't have to change anything is because we had not tied ourselves so strongly to very specific aspects of the operating system and kernel. So that's the good news in terms of how Postgres is positioned in the cloud, whether it's virtual machines or containers. However, when we're looking at where we are in terms of integration with some of these orchestration tools, particularly Kubernetes and others, we have some work to do. I know there are some organizations, and I believe it's Crunchy has a Kubernetes kind of tooling solution. I know Enterprise DB has one as well. And what we're doing is they're developing sort of tooling orchestration processes around Postgres that make it easy to deploy. The question we have for as a database are these things that should be in the database, or these things that are best off developed by people who are specifically working on those clouds? And the question we've had, particularly for the cloud vendors, is what things would you like to do with Postgres that you can't do because of the way Postgres is designed? And I know I've had this conversation with Microsoft. They've been one of the more vocal ones coming to the community and saying, hey, here are some things that we would like Postgres to do so that we can better deploy Postgres in our cloud, whether it has to do with monitoring what Postgres is, whether Postgres is up or down, or monitoring what IP addresses are being used by which machines, and whether we can switch IP addresses while we're running, and port numbers. There's all these kind of things. And what we'd like to do as a database, at least initially, is to get a list of the things that we need to do to make orchestration easier for people who are writing orchestration software. And then once we do that, then we would decide, are we really ready to bring in something that, are we ready to ship a binary that knows about Kubernetes from day one, right? That effectively you don't have to download anything else. You just download Postgres and it understands that orchestration. And, you know, getting back to the previous case, is that really something the database should do? Or is it better off being done by somebody who's focusing on the particular cloud deployment? Because Kubernetes is popular, but if we look at the cloud, you know, pantheon of things that we have, you know, there are a whole bunch of other OpenStack and Azure and a whole bunch of other orchestration setups that we could potentially integrate. And the question is, do we need to integrate those, or do we just need to give users a better experience of how they could write orchestration software to work with Postgres? And I think that's really the unknown.
Bruce, a small question regarding the most not so technical things about the clouds, but maybe ideological, I would say. The things you just explained show us clearly that maybe the main good thing about Postgres for many people can be confused in that way, because many people actually enjoy that Postgres is quite independent technology, not dependent on a single company, many companies contributing to the single piece of code, and so on, and to that ecosystem. But the cloud, actually, it's more like a proprietary operating system, because there is no true open source cloud. It's usually controlled by some company, and most likely nobody knows what is inside. So this binding PostgreSQL tightly to the cloud, is it a good thing from your point of view or not, and what we can do about that?
Yeah, I mean, I can imagine bringing in a Kubernetes thing and then some of the other competing orchestration tool, you know, settings, you know, getting upset at us and saying, hey, you got a hook for those, but you don't have a hook for somebody else. And that actually goes all the way back to what we talked about in the beginning. When you have multiple ways of doing something, it's unlikely that Postgres is going to be integrating one of those many approaches into its actual executable. I do think there is room for, I think there's room for more of a hooks and making it easier for these people. What the thing that shocked me, though, in talking to Microsoft, is that when we asked what things would you like Postgres to do to make it easier to deploy, I mean, they asked for like these tiny little things. Like, I was like, they're like, well, when this happens and that happens, it would be nice if you could get Postgres to do this other thing. And I'm like, gee, if that's the biggest problem you have, I'm feeling pretty good, you know? So, you know, I would say in a lot of ways, it actually works well. And the kind of things that these orchestration frameworks want are pretty minor. They're actually very easy. It's actually very easy to orchestrate Postgres. It's really just a question of somebody sitting down and writing code to do that. Again, I have been impressed with, I believe the Crunchy Data Kubernetes is open source, which I think is very nice. The Enterprise DB one, I think, is closed source. So that's a little less attractive to people who aren't Enterprise DB customers. But I believe that we're back to the same problem that we had before, that we were requiring people who have the database to download something else to do connection pooling, to something else to do orchestration in cloud, or something else to do backup. And it is frustrating. It is frustrating. I would like, and I'm hoping that some of the new focus we have as an organization is to try and give people a better direction of how I can improve. What do I need to, what should I be downloading in addition to Postgres to get my job done? And a lot of times that information has not really been clear.
But many people actually decide to go to the massive cloud provider in that case. So they go to the Google, to Amazon, and use Postgres there. And in that way, actually...
Postgres, right? Managed
Postgres, I mean the database as a service. And in that case, practically, it's the way to proprietary software, because we cannot see what's inside. And in that way, the community contributes to closed source things. By the way, what actually do you think is it danger for community or not, from your point of view?
I will add some
Please.
like 2 cents. Like take Heroku, for example, or RDS or anything. They say we created replica for you, and we have auto failover, and we keep replica on different availability zone. And you don't need to care about anything, but you cannot test it actually. To test it, you need to break Postgres, like, but you cannot break it actually, because, and it's like in RDS at least it's forked version. I think Heroku it's not forked. I'm not sure about Google and Microsoft, but for RDS it's
nobody is sure.
Yeah, nobody can test their actually their replication and auto failover, and the best decision you can make is just keep another replica to have at least anything in case they fail. These days we have Intel bug and all these CPU related things. Nobody can trust nobody, right?
Right.
So this can be a danger of using managed Postgres in clouds, right? But I see a lot of companies here in California use it. More and more adoption. It's increasing, right? So what do you think about it?
You're absolutely right that because your point is that because Postgres doesn't have auto failover, there is an increasing desire for people to use a managed service that provides that. And by definition, the managed service is going to be closed, right?
There are few things that people want from Postgres to make them go to managed clouds. It's very easy creation of replicas,
right?
And auto failover actually, and backups.
Right.
So these things actually, and that's it. And because you still need to understand which random page cost you need, and so on. You still need to tune it and so on. But these 3 things are main reason they do it.
Right. So if you look at the solutions provided by Azure and Amazon and Google, you look at their failover solutions, you look at their backup solutions, right? You look at the replication solutions. In almost every case, those are specifically tied to the features available in their version of the cloud, right? So in Amazon, they're using S3, they're using snapshots, using availability zones, right? On Azure, they're using their own whatever, right? And Google's doing a similar thing. So the problem is that even if Postgres, so I guess my problem is that I doubt we would be able to provide a solution for failover and backup that those cloud providers would use, because they want to use something native to what they're doing. But the problem is that because they're having to use 3 different solutions, it's almost proving that there is no one solution to this problem. And in fact, the best solution for each of these problems is really tied to whatever infrastructure you're on, right? So it's a kind of case that it's really hard to say this is the failover we're going to use, because when we look at the cloud providers, they're all doing different things, trying to leverage the strength of the infrastructure that tooling that they happen to have. So I guess in the same way that Postgres never relied on the operating system to do something, it never went around the operating system in a way, in a case the operating system could perform that skill. We're probably following the same path in saying we're not going to reinvent these other things if there is a capability for an external tool to do this. And there's so many different ways people will want to do this that we're probably going to keep it external. If there was a sense that there's probably only one way you're going to do this, there's only probably one way you're going to set up a replica. There's probably only, look at PG-based backup. That's a good example. So for setting up a replica, PG-based backup takes a whole bunch of smaller things that you used to have to do and bundles it into one executable, and you can just run PG-based backup and it pulls everything over. And
sorry I must interrupt you. I have some experience with RDS last year.
Yeah.
And, when you create a replica and it's alive, it is very slow for an hour or two, because they actually don't have real data on replica. They're still pulling from an S3 backup.
Oh.
It's called lazy load. It's documented, but nobody knows when start using it. And when you consider it's very, very slow, you start contacting support manager, and he says, just read about lazy load feature. It's our feature. And the best advice, you need to select stuff from your tables to speed it up. So
yeah,
it's very, very proprietary thing, right? So like connected to their infrastructure, right? So
yeah, it's going to be connected to their infrastructure. Whether we could improve that somehow, I don't know. We've talked to the cloud providers, we've talked to people. The problem, to get into the specifics, the problem with auto failover is you have to have some type of watchdog process running. So by definition, it's going to have to be a separate executable. And then you've got to have it know about the network topology. It has to know about how to set up a virtual IP. It has to understand the network stack. It has to understand how you do network configuration at the OS level, or at least call command utilities to do that. And then you often need a capability of shutting off a server. So, shoot the node in the head kind of thing. So you're looking at interaction with hardware and shutting things off. And that's really hard to set up, even on forget the cloud setup, but even in a data center that you control, that's often fairly difficult to set up. And the idea that we would kind of bring that into Postgres and have basically specific code for every OS to figure out how to do all these things, and then we have to interface to all these other hardware devices that shut off power to things, and a watchdog that always has to run and then report to people and all those stuff. You start to see all that stuff out there, and you're like, wow, maybe it is better as a separate tool that you can download, that you can configure, that can have its own bug fixes and so forth, because its interaction to Postgres at this point is pretty minimal, right? The failover part of what a server has to do for failover is not a whole lot. There isn't a whole lot related to the database. It's mostly about shutting it down, its IP stack, its virtual IPs, and it's shutting off power to the old server. That's not really a database project. That's almost like, what would we even do inside of Postgres to do that? So, I guess we could eventually get to a point where we had a separate binary that did this kind of failover thing. But that's, whether that should be shipped with Postgres or it would be something that you just install separately, I don't know. I think the bigger problem is that nobody externally has sort of sat out and developed an overarching solution to this. So I don't have anybody externally working on this. There is one or two. I'm trying to remember there are a couple external tools that do some of this, some of the failover, and I'm trying to remember the names. If you can remember the names.
You're probably talking about second quadrant rep manager, about Patroni and things like this. So Patroni from Zalando.
Right. Thank you.
But actually, it looks like a bit confusing. You describe things, and you're talking about after failover. And I'm listening to you, and it looks like you're talking about how features got into the core. Like, it should be someone who knows about all the server, who should know about topology and so on and so on. It just looks like community reached the consensus. So it's the same difficulty of the problem. We need It looks very familiar.
You look at it, you're like, wow, it requires a lot of knowledge about non-database things to get it done. And you're probably better off relying on something like Rep Manager or, Enterprise DB as a tool. I think a lot of the vendors have tools. Postgres Pro probably has one to do failover. And frankly, one of the problems we've had with failover in Enterprise DB is not the software, but the fact that you got to configure it, and configuring it and testing it, as Nikolai said, is pretty tough. You've got to look at all the possible failover scenarios and make sure that it handles them all. So for me, a lot of it is configuration and actually setting it up. And I hate to say it, but that's what the cloud providers do well. Is that at least reportedly they set up these things so that they work,
because they have no such constraints, maybe.
And the problem is that when you're doing a failover in a single data center, you almost by definition have to have somebody of our capability to set it up, right? You can't set it up yourself. I would almost argue against that.
So we should have some sort of programmed Tom Lane for failover.
Yeah, you should have. You need to have somebody there who understands both the database and the network topology and all the ways that signaling can fail, that network cards can fail, that power can fail, and sort of walk through some of these to make sure that the system is properly failing over. Because if you, as Nikolai said, if you don't test it, you don't know it works, you might as well assume it doesn't work, right?
I've actually met a couple of persons of that knowledge, and most likely, I must admit, they fail more frequently than database.
Right. So what happens is you have one data center, you're doing this, and you've got to bring in experts to set up just your data center, right? When you're doing this on a cloud scale, then obviously you have a team that just focuses on that, and their cost of their infrastructure, and there's a certain economy of scale of doing failover in a cloud that's harder to do in a single data center, which is why the cloud, one of the reasons the cloud has become popular, because there's an economy of scale in terms of not requiring as much administrator maintenance per server. When you're when you're maintaining thousands of servers or millions of servers, you can automate and test and economy of scale a lot of your effort across all those servers. If you're doing it in one data center, you really can't do that. So I don't think the problem, I'm not sure if failover actually is the problem primarily of missing software. In a lot of ways, the problem is the problem of requiring somebody to set it up and requiring somebody to make sure it works. The software is almost part of it, but it's only half of the job. It's not true of the database. Pretty much people set up Postgres and run in production all the time, and they don't need that kind of sort of specialization. But when you're that's because the database is operating within an operating system that it assumes is stable. And when you're looking for failures, you're now looking at power distribution, network distribution, network topology, virtual IP, all that other stuff that can go wrong. And all of a sudden, it becomes very much about my particular configuration and my particular site, my particular data center. And therefore, it's very hard to automate those things. And to even to embed that smarts into software becomes very difficult.
Okay. Let's switch to more like internal things, to more Postgres core related stuff, and dive into there. I have two questions related to vacuum. And a few days ago, Robert Haas wrote an article about state of vacuum, and I saw a discussion on Hacker News, and like actually several questions here. First question is, I saw this question is always there. I mean, it sounds like, do we still need vacuum? You know, like,
yeah,
can we be without it?
Right.
And
could we finally turn it off?
Turn it off, right?
Can we imagine Postgres without auto vacuum and vacuum at all?
Right. So I've obviously done some research with, and I think I have good news and bad news.
Okay.
Yeah, I mean, I guess most of it's bad news. I guess the first bad news is that we've probably taken vacuum and auto vacuum as far as we can go. I mean, there's some optimization. 64-bit OIDs are going to 64-bit transaction IDs would eliminate the need for freezing, for example. So that would be a win. We're talking about that. But there's still always but when we look at how much we've optimized it, we've probably taken it pretty far. The downside is there's always going to be a need in any database, no matter what the architecture, whether it's MVCC or not MVCC. There's always going to be the need to reclaim the space of deleted rows and reclaim the space of aborted transactions. Okay.
To support concurrency, right?
Well, just, you know, it's even true in a file system. So when you delete a file, you know, the kernel kind of goes around and it just puts the blocks on the free list, right? When you delete rows in a database, it's a little more complicated because the rows are are much more granular than 512 byte disk blocks, which is the way normal file systems work. They're intertwined in all sorts of different places. So, you know, imagine you delete, you know, every other row in a table. Well, obviously now you've got these holes in the table of data that you don't need anymore. And they're going to have to stay around for a while, but eventually you got to get rid of them. And every database has to deal with that problem. I mean, the way a text editor does it is if you delete a couple rows in a word processor and you save the file, it effectively just overwrites the whole thing, right? You know, if I have a little word processor, I delete a couple lines, I save it, it's just going to write the whole file to the file system. Well, that works for a file, a document, but it's not going to work for a database because we can't have us rewriting gigabytes of data every time somebody adds a row. So by definition, we have to have some type of housekeeping, right? Very similar to the JVM that has a memory garbage collector that's looking for free memory and kind of recording it so it can be reused. In the same way, you're going to have to do that for for a database because the granularity of the data you're deleting is going to be smaller than the total data size, right? So that's why file system changes and database changes sort of are at a different scale, because you're normally making very minuscule changes to very large files in a database, and in a word processor, usually it doesn't matter. Files are so small. So you're always going to need some type of garbage collection. So vacuum can never go away because effectively even the JVM has its garbage collector, right? Let alone Oracle or any of the other DB2, any of the other operating databases have to have some way of recovering deleted rows or aborted transactions. The reason Postgres appears to be heavier in its cleanup is the way it implements MVCC, right? And this is somewhat covered in my MVCC talk, where I explain toward the end, we always need cleanup for these things, but now we need cleanup for updates. And it's been argued.
I tweet with a link to this PDF to your talk.
Thank you.
Regularly, like referring, like this is classics. You need to reread it
Yeah.
sometimes. Yeah.
Yeah. But be ready to sit down for a little while to watch it. So
you mean that if I didn't follow to the idea of having different storage engines in Postgres, but even in case of having different storage engines, you mean that all will need some implementation of cleanup engine, right?
Right. So that's where I was kind of getting that there has been good and bad about the way Postgres. So we're always going to have to clean up for deletes. Some sense we're always going to have clean up for aborted transactions. The question is that Postgres has additional cleanup for updates, and this has always been a contentious issue. There are some major advantages to the way Postgres does it, and there's some major disadvantages to the way Postgres does it. The advantages, so in summary, normal databases like Oracle, when they do an update, they copy the old version of the updated row to an undo segment, and then they put the new row in its place, assuming the new row is the same length. And if it's not, they have to figure something out. So there's a lot of complexity about having to write a row that's still live effectively until the commit, and also to honor existing running transactions. That row can't be overwritten. It's got to go somewhere. So it goes into that undo segment, and queries that need to look at that row actually need to hop off of the table, go to the undo segment, and come back and continue their scan. So, if you've ever, the snapshot too old error was an old error that Oracle used to have. I don't know if they still have it, but it's related to the fact the undo segment got too big. So there's a lot of complexity related and overhead related to this undo segment. The undo segment becomes a hot spot in the system and so forth. So Postgres, its original architecture didn't have an undo segment. We decided, I remember Vadim Makayev asking, do we want an undo segment? And we kind of looked at it and we're like, that sounds really like a lot of complexity that we don't need. Let's just stay with the architecture we have, so that in Postgres, the update, the old row stays in its location. It isn't moved. It isn't overwritten. New row goes in its place. And then later, either with a single page vacuum, single page pruning, a hot update we call it, or from vacuum, that row is then reused. That row space is then gets reused. So, yeah.
Actually, Bruce, can I actually ask you about the another one maybe connected limitation of Postgres in that way? And it will be interesting if you explain if it is that limitation or not from your point of view. You mentioned that all databases need to put the old data somehow more effectively to update and so on. Many databases actually use multi-thread things to optimize the process. So basically, current implementation of Oracle undo heavily rely of lots of undo segments, and actually all those Oracle processes, they have a lot of multi-threaded things inside each process. Is it a limitation for Postgres which actually stops us from having more performative write things like auto vacuum, like updates, or it is not connected so directly on Postgres now?
I wouldn't say that is a limitation. I mean, the nice thing about the Postgres architecture to me is that all of the cleanup that we're talking about, whether it's a pruning or it's a vacuum, is happening in the background. And what happened with the overwriting MVCC, which we'll call the Oracle MVCC, or overwriting MVCC, which Postgres does not have, they basically created a very complicated hotspot of an undo area that they have to manage, that they have to grow, that they have to prune, and so forth. So they ended up pushing their cleanup effectively into the undo segment. So instead of having to do a cleanup effectively once in a while with a sequential scan, which is the way Postgres does it, they're doing their cleanup using these background threads inside the undo segment. Okay, so the advantage to that approach is that they've centralized all of their undo cleanup into one area. The problem is that other people are also reading that area at the same time, and it becomes a really difficult thing. So I don't actually know whether that overwriting undo is good or not. I know that once you go down that road, you're going to have a whole bunch of issues that are going to be issues not necessarily for cleanup that run in the background, but you have a lot of complexity now in the foreground of sequential scans and in the foreground of queries that have to be dealt with. And then you have to start putting threads and stuff in there to try and mitigate the road you went down by having this complexity necessary in the foreground of the process. See, one of the architectural approaches to Postgres is that effectively we just leave the old road just sitting there unchanged, right? And because of that, there really is no overhead in foreground processes. Yes, what happens is that foreground runs very quickly, and then you've got these vacuum processes which are generating I/O, but they're running in the background, and they're doing the cleanup. So you see more, I would say you see more cleanup visible on Postgres because it's all centered in a background process. It's not in the foreground. It's not trying to reach into an undo segment that is trying to be cleaned up at the same time, and a lot of these other complexities. So I think the Postgres approach of having a non-overwriting storage MVCC probably is a cleaner solution and an easier solution in terms of performance reliability and code accuracy. However, as you alluded in your comment, we're starting to research whether we should be considering another type of storage manager, still MVCC, but one that does overwrite in place, because there are certain pathological cases where MVCC does not work, where our non-overwriting MVCC does not work well, and cleanup doesn't work well. And I think probably the classic case is the one that Uber complained about, but it's not unique to that. There are other settings for that. And the question is, can we develop code which runs as good for all workloads, or the majority of workloads, using an overwriting storage manager, which we'll switch to it? Or do we need to offer an option of a non-overwriting storage manager as a separate storage option for certain tables? And I think that's really where we're in the process of looking at. I know Second Quadrant was looking at pluggable storage, particularly for columnar, which is another area we're lacking in. And I know Robert Haas is working on something called zheap, which he's thinking of as working as an overwriting storage manager, but also maintaining MVC semantics. And I don't think anybody really knows how that's going to play out. I think the good news from my perspective is that when you put Postgres up against Oracle in pretty much any benchmark, we come out very close. And some cases better, some cases worse, but it's not a slam dunk that an overwriting storage manager somehow is better in all workloads. And I'm not even clear if it's better in the average workload. Because if you look at how much engineering Oracle's had to put into that undo segment, and there's still only parity with us, right? And we're sitting here saying, "Oh, it's storage manager. We haven't touched that thing in years," right? Because we don't have to. We've centralized all the cleanup in a separate process that doesn't interfere with the foreground, and foreground processes run at virtually I/O speed, as quick as they can get the data off the disk. They're not locking and getting mired in a whole bunch of very complex technology.
I'm afraid right now a lot of Oracle people will join this hangout to watch what we're talking about Oracle.
So I think we're researching whether, I think at this point with a pluggable storage manager, we're going to start researching whether an overwriting MVCC actually has benefits in some workloads or the majority of workloads. I think we're at that point where Robert Haas is looking at that kind of question. And I don't know the answer. I think it's good that we're looking at it. And I can tell you that I've talked to Oracle engineers and I explained how our system works. And I remember one of them telling me, gee, I really wish we had gone that direction, because it's just that what they've bought into by overwriting those rows and moving them has opened so many problems that we don't have. And if we think of the limited engineering capability we have, and the thought of how much would have to go into making an undo work well, I don't know. I don't know if it's going to be a win or not, but I'm glad we're looking at it, and I think we're eventually going to have an answer. But I do think we're going to find that probably it's only a limited set of use cases that actually would win. And in an ideal world, we'd have a little switch and we could just turn it on and off or whatever. Or, if somebody does like a big delete on something, it would be cool if we could auto overwrite. Like, I don't know. I think we're still in the research stage. I don't think we're really coming at this from a point of, we don't have an overwriting storage manager and therefore we're terrible in benchmarks. That's really not the case. But I do think there are workloads where we're not performing well and where overwriting storage managers are performing better. The question is, can we make that part of Postgres to some extent?
Cool. I think we covered vacuum topic really well, but I still have some questions. And this question is very down to earth, actually. But before I ask it, let me cite a couple of sentences from Robert Haas' article. So vacuum has come a long way, but it still needs monitoring and management. Small installations like the first ones I used running a current version of Postgres may never need to do anything about vacuum at all. And even larger installations will typically experience fewer problems today than they would have in earlier releases. At the same time, for large installations requiring consistently good performance, vacuum typically requires at least some monitoring, management, and tuning. And time will tell what improvements future releases will bring. I have a question. For years, we have big queries to telling us what is bloat level. Mm-hmm. Right? There are some versions from Postgres experts. There are some other versions, and I constantly see, because I'm daily posting articles to my Twitter, like 10 articles per day or so, because number of articles in Postgres community increasing constantly also. And each year I see new article. We will explain you how to monitor your bloat level in your tables. Last one was from Citus data, and it was actually referring to Postgres experts query, and that query is based on other query, and there are some other. So, like 2 months already, I'm hunting for a good way to monitor bloat. And recently, I understood that there is no one. There is no single query which will tell you real level of bloat. All they are wrong and show incorrect bloat in case you have if you have table integer 4, integer 8, integer 4, which will involve alignment padding, 0 bytes inside pages, right? All these queries, and including queries which use PG-stat tuple extension, which are usually considered like 100%, or at least the most exact one, they produce some load on your table, so you probably don't need to run it on production. But all they are wrong because of alignment padding, actually. And I spent several days already trying to fix it, and it's actually a tough question how to monitor table alignment and find this is like the error introduced by it to this bloat monitoring. And I want to connect dots here. Vacuum monitoring and things nice to have in core. Isn't this thing one of those that must be in core? Bloat monitoring and vacuum monitoring and so on.
So there's probably three bloat areas that you've discussed. So the first one, probably the smallest one, is the alignment padding. So the alignment padding is there, and I do have an internals talk. I think it's called Inside Postgres Shared Memory. And what that presentation explains is that Postgres, when it accesses data that is in a table, effectively just copies the 8K page from the disk into shared memory. And when a backend needs to access an integer or a string or a float, it effectively is given a memory pointer into that shared memory. So because the way we store the data is identical to the way we're accessing the data at the CPU level, we have to align our data to match the requirements of those CPUs. So certain CPUs have major penalties for unaligned access. So it's really impossible in our current architecture to eliminate that alignment padding. I'm not sure I call it bloat because the bloat assumption is that your system starts compact and then it over time it gets more and more junk in it. For this case, it effectively is always the same. You're always going to get the same amount of padding. There have been talk about reordering the columns to reduce some of that alignment.
The main problem is that all bloat estimation queries, they don't understand alignment.
And they don't understand what. Yeah.
You create a table, like I said, integer 4, integer 8, integer 4, and they all show like from 10% to 25% of bloat level.
Really?
Yes, and I wonder why so many people don't care about it. Still.
That's interesting.
Yeah, I'm going to write an article about it, I think.
That's interesting. So the next area of bloat you talked about is the heap bloat of deleted rows and aborted rows and stuff like that. And the reason we don't have a single query that gives you the answer is that they're all by definition estimates. So what those queries do is they kind of they look at how many rows are in the table. They estimate.
I cannot agree with you because PG.io user tables.
Yeah.
It has that tube.
Right.
So it's also estimated, and sometimes very bad estimation, right?
Yeah.
Right.
Yeah.
Okay. So why we have these and we don't have some really?
We need to remove those estimation also.
Oh, okay.
No, but Vacuum uses that estimate as an estimate of when it needs to kind of go in. So there is actually a use case for it. But I understand your frustration because it feels like there's a million of these bloat queries, and they're all having to balance between the problem of not using too many resources and getting an accurate number. Right? Because we can easily scan the whole table and give you the absolute correct number, but nobody wants to scan the whole table to do that. So you end up randomly sampling, which is the way optimizer statistics works anyway. You end up randomly sampling, but everyone has a different idea of the best way to get these estimates and how many samples you should make and how you should skew this and that. And it feels like it's an art that just keeps kind of because nobody, if people were willing to run a query that scanned the whole table, we could canonically ship that and say, this is the number for bloat. But because every person has a different, this is getting back to what we talked about earlier, everyone seems to have a different idea of how to do this. So you have 20 people who all have a different way of doing it. And how do you take one of them and sort of enshrine it as your official one when everyone has a different way of doing it? The other area of bloat that you didn't talk about is index bloat.
Well, one second.
Yeah.
Sorry.
Yeah.
Ilya has a huge experience with DBA in Postgres, right?
Okay.
So I will ask Ilya, have you ever seen, we know that default settings for vacuum for auto vacuum to start actually vacuum is when number of dead rows exceeds 20%. This is default, right? Mm-hmm. So Ilya, have you ever seen when you need to increase these settings? Not decrease, but increase. This
actually,
is a question, of course.
It's a very good question. We once upon a time we had this discussion with several PostgreSQL DBAs, I believe several years ago at the Regulated Industry Summit or something like that. So how should your PostgreSQL installation looks like to disable auto vacuum at all or to make it very, very unaggressive? And the idea was the only goal for that is if you have a very short-living PostgreSQL installation which not supposed to be updated in any way. So basically, those defaults are very hypothetical thing to very, very specific, very narrow set of workloads. Like if you have some database there, the data doesn't change at all. But actually, the good question is, in between of aggressive settings, then you trigger after vacuum after less than 1% is changed. And between the default settings, what is the correct value in between? Because if, for example, you have bad disks and you set very aggressive settings, most likely you can kill your disk system. And we have processes in Postgres. So basically, auxiliary processes, now it's auto vacuum up to 20 workers. It's background workers for parallel queries. It's log sender, log receiver, and so on. So basically, we need to have a very powerful machine to achieve those proper aggressive settings. So I would say that defaults are certainly not the case. But where between the defaults and the aggressive 1% we should stop? It's a very good question, actually.
I see. But what we have now, it's most OLTP installations where team has no DBA. They have 20% default and very bloated tables, right? And this is a very, very common situation, right? And there is no nature any query which will, or any internal number which will show them that you have huge bloat. Actually, they don't know it, right? So this is why this question is I think important one and probably need to be changed internally, right?
Yeah, and I think it's going to get worse. And Ilya actually alluded to it. So, I mean, I have a blog post probably from last year that talks about the idea of having vacuums defaults become more aggressive when the machine is not busy. So it actually shows you
like at night. At nights, right?
At night, right. So basically you can very simply do alter system, set that percentage from 20% to 10%, do a reload of the config file, right? And then when you do, and what's going to happen is it's not going to force it if there's very little free space, but it takes it from 20% to 10% at night. And then during the day, it takes it back to 20% again, right? Very simple stuff, right? But the problem is that nobody really knows when busy is, right? So you have to orchestrate that for every single installation. And it's getting worse because, as Ilya said, we have parallel workers that we're going to have to configure, and you know, sort of background stuff that we're going to have to configure. So in a way, the ability of the system to adjust to parallelism, to adjust to background workers and so forth, is almost a separate thing that we need to start doing. And unfortunately, because of the way Postgres is designed, we have to decide as a community, is this something we're going to be able to monitor in the database and tune those live so people don't have to deal with it? Or do they have to download a separate tool to do that? Or are we going to have a monitoring tool do that? I don't know the answer. But as we get into these larger installations, we're really getting to the point where having static values, whether it's for auto vacuum or for parallelism, is going to continue to be a bigger and bigger problem, and eventually we're going to have to deal with it, right? I feel like vacuum and parallelism, which you would think are unrelated, are actually a question of how do you make the best resources, how do you make the best use of resources on a machine. And I feel like we just haven't addressed that. We're just like running away from the problem and not actually saying average DBA would actually have this, and we should be able to give people better answers. I'm putting blog entries out, but that's probably not enough. We probably need to have a more serious discussion in the community of how to make use of some of these things, how to make use of bloat measurements and report to people and so forth. These are the sort of edge things that, as again I said, the community doesn't seem to do very well. They assume everyone's an expert, is going to create a cron job and whatever. I don't know, but we know that that doesn't happen very often.
Okay, I have some questions from audience which I have to ask. It's already like it's from different areas. Do you know some good examples of success stories for Postgres in banks or financial institutions?
Yes. So the funny story is that originally when I started with Postgres, I used to say, you know, it's good for a small to medium sized, you know, or organization, but, you know, you couldn't run a bank on it. And within, I guess, 10 years, around in the mid 2000s, you know, we started to have banks using it. So most of the large financial firms in New York use it. A lot of the hedge funds use it. In fact, the hedge funds use it not only as a database, but they use PLR, the statistical and analytic, because PLR allows them to do some very cutting edge data analysis for hedge funds, looking for trends. That's actually really interesting. So that's actually a really cool example.
Do they actually storage procedures with PLR or are outside of
No, they do use PLR inside, because we're the only people who can do it, as far as I remember. I think maybe I think Microsoft can do it now, right? Maybe PLR. Do they use R?
I'm 100% sure that PLR is not available on RDS, but I don't know Microsoft. So PLR is created by Joe Conway, right?
Right. So that's an interesting case. The Federal Reserve Bank uses it. They've used it for probably 12 years. So that's been very. So then I stopped telling people that banks. I couldn't say that banks couldn't use it, because obviously they were, right. So then I started saying, okay, you can run a bank on Postgres, but you probably can't run like a credit card company on Postgres. Well, that went away last year when MasterCard standardized on Postgres. So I don't have really a case. I can't say it's useful anymore. I guess there isn't anything that's too big anymore for Postgres. I do feel that we have work to go in terms of big data. So I think in terms of sharding for very high write workloads, I think we still need to do work there. But in terms of operating on a single machine, where, you know, obviously MasterCard did all the testing. We actually run very well on the Oracle hardware. What do they call it? The
Exadata.
Exadata, yeah. We actually run as well as Oracle and Exadata. So it was kind of a hilarious thing, because MasterCard said we got a lot of Exadata machines. Can we still run Postgres?
I didn't know this. Cool.
Yeah, and we're like try it. I mean, they had an independent lab test it, and it works great. So Yeah, so I think that there really is no barrier to Postgres in the financial field. And it's been embraced very strongly in the, obviously, if you got MasterCard, you got the Federal Reserve, and you have all the banks in New York using it, that's obviously really good. So yeah, I don't think there's any limitation there. And a lot of people like Postgres because of some things like PLR and the ability to customize it. They've been doing some interesting customizations because, as you know, the financial firms in New York are always looking for a competitive advantage. And one of the competitive advantages they see in Postgres is the ability to put certain customizations in there to give them a competitive edge, and that's probably one of the reasons it's been so popular.
Mm-hmm. Interesting. Next question, somehow related to the previous one. I think it's actually from people who participated in migration from Oracle to Postgres. Will be any changes to PGDG at all? For instance, can we expect that it will have packages like an Oracle? I know. I know that Tom Lane is doing some work. I've noticed in Hackers mailing list that is doing some work to optimize PGDG code, and he recently fixed some errors inside it, and some optimization is happening. But packages is one of among very desired things. I know it. From there is also user echo forum for Postgres. I don't know is it official or not, but it's like top 3 thing people want.
Right. So I did a blog post last year about PGSQL. There was a long thread that I linked to in the blog, which basically says, okay, we've got PGSQL. What can we do to improve it? And one of the surprising answers was that the number of improvements in the area people wanted to improve were really small. The biggest complaint was, I think there was a couple cases where some of the syntax was more verbose than it needed to be. So they wanted to not have to type. They wanted some defaults to be different in the language.
Like catch and exceptions is
something like that. They wanted not found to be different behavior or whatever. And I kind of came away, and it is a very long thread. And the blog post is actually pretty long, but it kind of outlines sort of what they found. So with syntax, it was some of the defaults they didn't like, so they didn't want to have to type extra words. But when you looked at the actual complaint of what it was the matter with it, it really wasn't that big. Like it felt I felt very good that the complaints were so limited, and I even mentioned the blog post. But in terms of packages, the question we've always had is, I doubt we ever implement the Oracle syntax for packages, but we've always felt that the capabilities of the package, for example, the ability to bundle things together, the ability to have local variables and so forth, actually were very reasonable things to do. So I think we've been if you look at the to-do list, we've been sort of agreeing that adding some of the capabilities of packages into Postgres would make a lot of sense, but adding the actual syntax probably would not, for really the reasons that they outlined in the blog post. I mean, everyone's pretty happy with PGSQL. I realize it is an Oracle, and if you're trying to port Oracle directly to Postgres, it's a pain. And obviously Enterprise DB has that package language or whatever.
And actually, Bruce, many people who complain about PGSQL, they complain mostly, I would say, if they seriously complain about PGSQL, they complain about the performance in terms, then they have complicated logic inside PGSQL. They really lack enough Oracle way to have a compiled procedural language. And what's, in your opinion, can we see actually something like properly compiled procedural language in Postgres?
That's interesting. So I'm not sure I saw that in that thread, I did not see that discussion. And maybe it was more a discussion from language designers than actual practitioners. In terms of the reason, so PGSQL, you're right. Nikolai's right. Tom Lane has made some performance improvements in PGSQL. Nothing super major, but some small ones. PGSQL is compiled already. It's compiled to like an intermediate language that is, again, executed. The biggest complaint I've heard about performance for PGSQL is that when you are evaluating an expression, we are executing SQL to do that. And that's, I think, the biggest problem, that when you're trying to do any kind of complex logic in PGSQL, you're actually having to run an SQL query to do that computation. And that's, I think, where the big complaint comes. I think in Postgres 11, we're going to be having it looks like we're going to be having the virtual machine just-in-time compiler, and I'm hopeful that that's going to make the expression evaluation faster, because right now, when you're evaluating an expression in SQL, you're running through a whole state machine to do that. And I'm hoping that that's going to improve it. I don't know how else I'm not sure how else we could improve it, because the only other way we could improve it, and I guess the way Oracle did it, is to effectively create an expression execution engine inside PGSQL.
Yeah, some sort of bytecode of native code.
Not falling back to executing a query to do the evaluation, but in fact doing that inside. It's possible they have to do that because they don't have the kind of procedural language capabilities we have. So we know if you're going to do anything fancy, you do it in PL Python or PL Perl or whatever, PLR, certainly if you're doing anything really sophisticated. But in Oracle, you can't do that. So maybe that's why people are doing many more complex things in PGSQL. Normally, when I see PGSQL, I've rarely seen any kind of complex computation, because I see that in other server-side languages that people use. But if you're coming from Oracle, you don't have that. So
you most likely see how to do that in proper way. But many people migrating from Oracle, they have huge packages, as Nikolai mentioned, and crazy logic inside.
Yeah, I think if people would post a PGSQL thing that was slow, I'm afraid we're going to just kind of say, ouch, if we try and do that in PGSQL, we're going to have to put the execution engine, expression execution engine inside that PL language. And I don't think it's likely we're to do that, because it's going to be a lot of you're basically rebuilding the entire capability of Postgres, including all the functions, right? So not only would you have to have every function call all of a sudden would have to be ability to execute. So I don't know. I haven't. Yeah, I'm not sure how I'd fix that one. That's a toughie.
Okay. We're online like 1 hour and a half. So I like 2 or 3 questions left.
Sure.
And I will have another one.
Oh, okay, 4. So one last question from our audience is sounds like this: where could we expect breakthroughs in Postgres development? Probably there are some areas where some initial development is going on, and one could expect significant changes in the nearest future.
Yeah, so I think they're right. I think and that's a great question. In terms of a breakthrough for me is the ability for Postgres to operate on a problem domain that was impossible in the past. Whether we didn't have the feature, or it was too slow, or we couldn't handle those data volumes. For me, breakthroughs are not kind of a new function, right? But something that allows us to operate a new problem domain. If we look back at some of the breakthroughs in the past, certainly JSON is one, full text search, GIS, these are all breakthroughs that bring Postgres into new environments. If I look at where we are now in terms of development, I think the breakthroughs are mostly related to operating on larger data sets than traditionally we've been able to do. So if I look at partitioning syntax came in Postgres 10, but it really didn't change. It was not a breakthrough because it just made the DBA's life easier. It did not allow Postgres to process data effectively any faster than it did before. But if I look at what's coming in Postgres 11 and 12 in terms of partitioning, the ability to prune at runtime, the ability to do faster pruning, the ability to sort of add partitions on the fly and so forth. I think
1,000 partitions, maybe, like thousands.
Yes. Yeah, thousands of partitions, right. To be able to handle thousands of partitions. These are all things that are made possible by the partitioning syntax, but were not accomplished in 10. So I think that the partitioning workload and the ability to exploit partitioning, including parallelism of partition scans, is something that's going to be dramatic and a breakthrough in 11 and 12. Same thing with general parallelism. We've been working on that since 9.6, and we've had some in 9.6, some in 10. But again, we still are probably halfway in parallelism. And then I think also sharding, which we, again, have made significant strides in Postgres 10. Postgres 11 is probably going to be the first production level release that's going to support certain read-only sharding solutions. So I think when I'm looking at what we've accomplished in Postgres 10 and going forward, I don't see any. What I don't see is any new workload change. I don't see a new GIS. I don't see a new JSON, at least from what I'm seeing people are working on. What I do see is us working on more partitions, more parallelism, making use of multiple CPUs for data warehouse, and then big data workloads for things like sharding. So I think the breakthroughs in the next 2 years are not going to come with new workloads, as far as I can tell. They're going to come with Postgres moving into the big data, into the data warehouse space in a more serious way than we have in the past. And multi-node Postgres, I think, is going to open Postgres to a whole new class of problems that we could never do before.
Bruce, actually, I would like to ask you a bit different question, but as usually, it's well connected to our previous conversation. There is, I'm sure, the topic which everyone is worrying about now, the Spectre and Meltdown, this security flaw. And can you actually briefly explain us what is the state of art of those things, how they affected Postgres, if they affected? And can you actually say also if the community was ready to that? From your point of view, how community reacted, what Postgres is supposed to do with things like that?
Yeah, so we did have a long conversation within Enterprise DB and on the closed security email list, talking about how these would impact Postgres. And I think obviously Postgres being a high performance system and also relying on the kernel to do a lot of the operations, there is going to be significant measurable performance impact on Postgres, because, for example, if you're playing a video game, normally video games make very few kernel calls because they're doing almost everything in user space, and those type of applications are probably not impacted at all measurably by these exploits, because these exploits really are involved in the interface between the user space and the kernel calls. Databases obviously being reliant on the operating system, and Postgres probably more reliant than an average commercial database, although Microsoft certainly is very reliant. I'm thinking of Oracle, who has a tendency to do a lot of kernel stuff in the user space for whatever reason, is impacted. Andreas Freud, who is one of the community guys, an Enterprise DB employee actually, was quoted in the New York Times article. I don't know if you guys saw that.
I saw that.
That's
what
I was like, wow.
I've noticed that Postgres got its hype on this topic, actually.
Yeah.
I've noticed in articles. Yeah. So it was many times, even in Russian articles.
Yeah, and he did a great job of kind of jumping on it early, and because we're open source, we could kind of play with it. And I was just really excited he did that. That was great. So there's going to be some performance impact because we are going to be calling the kernel, particularly when we're reading or writing data. To the extent that it would slow down a vacuum, we really don't care, right? If it slows down vacuum, it's going to increase the CPU load a little bit, but it's not going to impact the front end queries as much, I think. If you look at the way Postgres defers a lot of its writes, for example, those writes are normally happening in the background by background processes, whether it's the wall writer or the background writer or checkpoints. Those actually don't impact Postgres very much. What we do find is that short-lived queries are most impacted because when you're pulling packets from a network, you're gonna have a hit there. So when we look at, for example, PG Bench, which is a TPC-B type of workload, you do see a measurable impact there. And I think we're still waiting to see what types of corrections people come at. If you look at who was told about this, I think it was really mostly Microsoft. Linux received not early notice of it, and I'm hoping that open source is going to do what it does well and find ways that nobody else thought of correcting this without major performance impact. So I'm running Debian here. I don't have the patch yet. I assume that some of the Linuxes are still waiting to get those patches released. In terms of how it would impact Postgres security, there was discussion in the exploit news that JavaScript could exploit this, which I was quite surprised by, considering JavaScript is a sandbox language. But there was an exploit of JavaScript, and I was surprised. So the first thing you jump to is whether this is exploitable by PLv8, which is our JavaScript engine. We don't ship it by default, but it is a language you can plug into Postgres. And I don't know if that's true. But of course, for somebody to exploit it, they would not only need access to PLv8, but they need to be able to create their own PLv8 function, which is probably, I don't know how many sites allow ordinary users to create PLv8 functions or create any functions at all, frankly. So to the extent that people can create their own server-side languages, those potentially would be exploitable vectors. We have no knowledge of these as possibilities. I've never seen a proof of concept even that this is possible. I think we're still trying to figure out exactly what the impact is. But from our understanding, the impact to Postgres is probably not at the SQL level. It would not be somebody who can we don't know how somebody who can run an SQL query would exploit this. We can imagine people who can write server-side languages potentially being able to exploit this. And I think that's about all we know at this point.
Yeah, great. That's a very fundamental statement.
Yeah. Okay, and final question about future. How do you see current state of Postgres community, and what are recent changes with community, and what are nearest future changes, and what are challenges for Postgres community? And in general, how do you see Postgres project in 5 or 10 years in future?
Right. So if having 21 years of history behind me, when we really started out, the challenge was that we were all doing Postgres in our spare time on the weekends. And obviously the first few years, that was my case as well. And, how do you build an enterprise-ready database when you don't have the type of time to take on some of these really big projects? So I was employed full-time from year 2000 forward on Postgres, but there were years that I was the only full-time employee. And I think Tom Lane actually was also a full-time Postgres person. But there was years it was just two of us, who had full-time ability to do this. Even our incredibly capable developers in Russia had other jobs, so they weren't able to spend full-time on it. But that changed toward the late 2000s, where we started to get first, second quadrant had a lot of people, Enterprise DB has a lot of people, then Crunchy and Postgres Pro has a whole team of people, NTT has a whole team of people, right? So now, if I fast forward to today, I think there was a sense maybe 5 years ago that now we had all these full-time developers working in all these varied geographic locations. And I don't think we properly coordinated all that effort. I think there was a lot of sense that Postgres Pro was doing stuff, and we weren't quite sure how that interacted with the community. And Second Quad was doing stuff, and Enterprise DB was doing stuff. And there wasn't the sense that I think we understood how we, as full-time people, all distributed around, could kind of accomplish some of the really tough tasks that we were never able to accomplish as volunteers. So, if you're fixing a bug, you can probably knock that off in a weekend, but you're not gonna do parallelism in a weekend, right? You're probably not gonna do parallelism in a year worth of weekends. So there was a sense in the mid 2000s that Postgres was kind of ready to start taking on things like parallelism and sharding and partitioning syntax and all these logical replication, big things. And we were just kind of held back because we didn't have these capabilities. And when I look at where we are now, when I look at sort of, I know Postgres Pro is working on some stuff, and NTT and Enterprise DB are working on some things here, and Second Quadrant is working on logic replication, some other things, and Andres is working on the JVM and the just-in-time compiler, and
they all have their own to-do lists, right? Like
they all have their own to-do lists, and I think they finally realized how to do those things, and also harness the capabilities of people who are not in their companies, because you can't just work on something on your own and just drop it. A lot of companies have done this. They spend forever working on this thing in their basement, in their own circle of company, and they just drop this huge amount of code on the community, and the community's like, okay, go away. Like, it's like, I can't review it. There's a million things in design that I wouldn't have done, and I don't even know where to start. And the person kind of goes back, and they're like, gee, this is, do I put it in my commercial product? What do I do with this thing? Right? I think every company's had that kind of problem. But I would say in the past couple of years, and if you look at what we accomplished in 9.6 and Postgres 10 versus what we didn't accomplish in, let's say, Postgres 9.2 to 9.4, right, which is a similar span of time, you have some major things coming in 9.6 and 10, and looking at 11, it's a similar bag. So I think we've had the ability to have a staff around and full-time and working on stuff for a couple of years. But it has taken a while for them to understand how to efficiently work and develop things as full-time employees, but also leverage the capability. So if you look at, for example, parallelism, who we had people from other companies helping Robert get that done, and logical replication, who's Second Quadrant, and you had other people from other companies helping that, and then the sharding thing and the foreign data wrapper stuff and all that thing that NTT and EDB are working on, and then we have people from other companies kind of working, Oleg, and working on second Postgres Pro, people helping them get that into something that's going to be acceptable to the community. So I'm feeling very good. I didn't feel very good a couple of years ago because I felt like we had a lot of effort happening in these companies that wasn't really generating any kind of useful benefits. They were not generating the kind of useful benefits they should. And I think now these companies are learning how to work as a team, both within their company and within the global community. And if you look at what was done in 9.6 and 10, I think you can see that, because as Ilya kind of talked about, Postgres is independent and always wants to remain independent, but we also want to harness the abilities and the time that these companies' employees have to move Postgres forward. And move Postgres forward not in terms of fixing bugs or adding a new function to something, but doing major architectural things, doing major feature enhancements that are groundbreaking, that are the types of things that are, foundational breakthroughs, and making that happen. I think we're finally there. So I would say now, instead of being in the let's fix bugs, which is where I started in 1996, fix the bugs, right? And then adding SQL standards capability in around 2000, and then adding enterprise capabilities, probably up until a couple of years ago, we're now entering the innovation phase for Postgres, where we're doing things that no one else does. And we're going to have architecture that no one else does. And we're going to be able to take on workloads and do things like JSON and sharding kind of capabilities that no one else has as an OLTP database. And I think that's where Postgres is going to shine. Doing what everyone else does is nice as open source, but doing stuff that no one else does, that people care about, that's really where you start to take off. And you said yourself, Nikolai, that there's a huge amount of buzz or a huge amount of interest in Postgres. And it's really kind of that needle starting to shift to say, I'm now using Postgres because it's doing things that are revolutionary and breakthroughs. And I think that's going to continue much more in the next 5 or 10 years than it has in the last 10 years.
Mm-hmm. This sounds cool. I mean, this looks like a major shift how Postgres is being developed, right?
Yeah, I would say it sounds hot, not just cool.
Yeah, but all these companies, they are competing with each other, right?
Right.
And all they have their own personal interest to earn money, because they are all commercial companies, and their primary goal is to earn money. And so most of them have like proprietary enterprise version. And don't you afraid that in few years they will more be interested in developing closed features for enterprise version, and the competition will increase and introduce some problems with such structure?
It looks like this period of time is in the past already in many ways.
I would almost say that. So it's a yes and no answer. So when I started with Enterprise DB, we were the only company that had a closed source version. Okay, so we've had that since 2005. So that's what, 12 years now that we've had a closed source version. And at that time, there was a question of whether that was the right solution. We have Enterprise DB has a closed source version, and they have an open source version, and they support both of them. And that was a very odd solution at that time, because even Red Hat had only really the open source solution. Although the way they did things and licensing, I'm not going to go there. But since Enterprise DB had both support for open and closed source Postgres, in the intervening years, that probably went 8 years where we were the only one. Then Postgres Pro had a closed source version, right? Then Second Quadrant has sort of an enterprise version that's open source to customers, but closed source to everyone else, which eventually becomes open source over a period of time. I'm not going to get into that. The point is that you had one company doing a closed source version of Postgres. Within those 10 years, you then had 3 companies doing that. Okay. SRA does have a closed source version, as I understand, of the Windows, but that's a separate issue. Fujitsu has a closed source version that's designed for their hardware. Okay. So you do have what I would say is a proliferation of these closed source versions of Postgres, which are also being supported with the open source. So these companies are not saying only our closed source. They're saying you can have our closed source, you can have our open source, you decide. And there are some business reasons that they do it. It's not always necessarily to make money, although that's part of it. But there are some cases, for example, for Enterprise DB, where they want to provide a unified solution for enterprises using Postgres. So they're going to have a backup manager, they're going to have a failover manager, they're going to have a monitoring tool, they're going to have a replication tool, and they need to make some changes in Postgres to make that work seamlessly. Okay. Whether that's good or bad, we're not going to debate that. But the point is that they felt a business need to support open source Postgres and have a closed source version, which to some extent may work a little better with some of their closed source tooling, although their closed source tooling also works with open source Postgres. So they got fit in both areas. Second quadrant, similar case. They have some fixes customers want. The community isn't going to put them in quick enough. They want to ship them. Or some enhancements that they want to ship to make Excel work better or whatever. Same thing with Postgres Professional. They have some things that their customers want. The community doesn't want it. You know, if you've got 5 customers and one of your customers wants this thing, you don't care about the community. I just want to give it to that customer, right? So it's not so much making money as trying to lock people in, but basically immediacy of needs of customers and the ability in Postgres to say, one of my 5 customers wants this thing. It's not going to impact anyone else. Just give it to them, right? And I think that that sort of drives it. Fujitsu, of course, when you want to customize for specific hardware, that's a great platform to do it in. Community's not going to want those changes, right? So that's that. I would say it's more of an from my perspective, part of it is wanting to make money. Part of it is just an operational requirement for meeting the needs of a customer pool that's much smaller than the customer pool of the community Postgres, right? So a lot of it's customization for your customer needs versus the global group that doesn't want this wacky feature in there that that most people aren't going to care about, because a high percentage of your customers do care about it. The good news, though, having so many companies now with closed source versions and open source versions, whatever, the good news is that over the past several years, you've seen a turn back toward the open source. So a re-emphasis of Enterprise DB in basically always not being known as the Oracle compatibility company or known as a company that just has a closed source version, but wanting to promote open source Postgres on the same footing as their closed source offering. Why would they do that? If it's just to make money, then why wouldn't they always just be pushing? It's because they see value in that open source message and that open source solution that is incredibly valuable to people. And if you look at Postgres Professional, they have a closed source version, but they also, I'm sure, support open source Postgres. And they're wanting to take some of their stuff and get it into Postgres so they don't have to carry that stuff. They want to get stuff out of, some ways, their closed source version and into Postgres so they don't have to have a closed source version. And the same thing with a second quadrant, trying to move over. I think Crunchy also has some open or closed source components like PG Audit. They'd like to see that go away and move that in. So I guess my point is, on the downside, we've seen a rise of closed source offshoots of Postgres in the past couple of years, but at the same time, it's not an irreversible move to closed source. As much as I've seen a closed source move in the past 5 years, if I look in the past 3 years, I've seen also a move back to the open source part. So I think it is something we have to keep an eye on. But I think the tide is moving back. As Ilya said, I think we've maybe seen the worst of we've seen the highest rise, hopefully, of closed source that we're going to see. I think we're still going to see it because I think the closed source, if we look at it as just a customization for customers, I can see that. You know, I can see customizing it in my own organization. If I needed something and it wasn't available, I'm going to just go into the editor. I'm going to change it. I'm going to go, let's run this version of Postgres. It's going to have this thing that the community doesn't care about, right? So I'm hoping that we're moving back to a case where most of the innovation, most of the making money is going to happen outside at the tooling level, at the support level, at the training level, at the configuration level. Setting up failover, have to have somebody come in from outside to do it if you're going to do it right, unless you're a genius, right? So I'm hoping for that. And also because community Postgres itself is getting bigger and bigger, companies don't want to be too far away from that.
Yeah.
And as we get bigger, I think that's going to also downplay the closed source emphasis, if you've seen that.
Yeah, totally agree. It happened recently with Postgres Pro's PG Pathman project. I heard that they freezed development of it because Postgres 10 got declarative partitioning, and it's better to develop this in this direction and improve and implement features from PG Pathman.
Yeah, and that's a great example. And you can't fault them because the customers needed that capability before the community could get to it. So what are you going to do? You got to keep your customer happy. Develop it, go, And now they want to move all that functionality back into Postgres. And some of the trimming, for example, code that it would allow for thousands of partitions may eventually come from Postgres Pro and go right into community Postgres.
Cool. Okay, I think we are done.
Yeah, that was a long meetup, actually.
More than I expected. It's almost 2 hours, and thank you so much for this very interesting event. I enjoyed it. Thank you.
Yeah, me too. It was a pleasure to talk to you, Bruce, as usual.
Yeah.
Thank you. Hopefully I'll see some people in Russia soon. So.
Yeah. Thank you. Bye-bye.
Thank you all. Bye.